a pencil in a glass of water at an angle with the glass, we observe pencil appears bent at the interface of air and water. It is due to the refraction of light. Firstly, observe the lemon, size of the lemon. Now, we place this lemon in glass of water. Now, observe the size of lemon. Now we observe size of the lemon is increased. It is due to the refraction of light. Now observe the passport size photographs through the glass of water. These photographs appears in enlarged in size. It is due to the refraction of light. Now see the actual size of the photograph. So we observe size of photograph is very small. Now observe again. So it is magnified. 5 rupees coin placed in the glass of water is appeared to raised up in comparison to the coin placed outside the glass of water. It is due to the refraction. We take an empty bowl and place a 5 rupees coin at the center of bowl. Now we take our camera away from the bowl so coin is not visible to us. Now we pour the water into the bowl. We pour the water gently so that coin does not disturb from its original position. Now see, coin is start visible to us. It is due to the refraction of light. Due to the refraction of light, coins appear to raised up. In the same way, bottom of the bowl is also appear to raised up from its original position. Now see the actual depth of the bowl from the top of the bowl. This is the actual depth. Now see from the side, bottom of the bowl is appear to raised up. That is due to the refraction. But when we see from the top, ray of light is going straight, so there is a no refraction, so we see the actual depth of the bowl. We are going to draw the diagram which shows the coin placed at the bottom of the container is appear to be raised up. So we already make some containers filled with the water. Now we draw the coin. This is the actual position of the coin. Now we also draw the apparent position of the coin. Now ray of light starting from the actual position of coin, it reaches at the interface of water and air. We draw another ray starting from the point. It also reaches at the interface of air and water. Now we are going to draw the refracted ray. To draw the refracted rays, first end of the scale at the apparent position of coin, and second end at the where the ray of light reaches the interface of water and air. Now we draw the refracted ray. This is the actual refracted ray. In the same way, we draw the second refracted ray. Second refracted ray starting from the apparent position of the coin and other end of the scale at the position where the second ray starting from the coin reaches at the interface of water and air. Now we draw the refracted ray. Here is solid line. Now we see that ray of light starting from the actual position of coin when reaches at the interface of water and air, these rays are refracted away from the normal. When these refracted rays are produced backward, they meet at a point. That point is the apparent position of the coin. So this is the actual position, this is the apparent position of the coin. So actual depth is this one, apparent depth is this one of the coin. To study the refraction through the glass slab, for it we already make a red line on the blank sheet. Now we are going to place the glass slab on this red line. Now you see that red line incident on the glass slab at an angle. Now observe line within the glass slab and line outside the glass slab. So you observe that line appears to be bent with respect to the line outside the glass slab. In second case, now we place the glass slab in this way that the light ray incident normally on the glass slab. Now we observe there is a no refraction take place. When the light ray incident normally, there is a no refraction take place. We are going to draw the refraction through a glass slab. For this activity, we take paper, scale, laser light, pencil, eraser, rectangle glass slab, D, paper pins, and in place of the drawing board we take a simple cardboard. We place a rectangle slab at the center of the paper and with the help of pencil we draw the boundary of the rectangle slab. Now we pick the rectangle slab. See the boundary draw of the rectangle slab. Mark one point at the one side of the rectangle slab. Now place D at the center of this point along the line of the rectangle slab. Now point the angle 90 degree. Draw the normal at this point. Now draw the angle 45 degree with the normal. Now draw incident ray. This incident ray is produced in dotted form within the glass slab. Now we place a rectangle slab within the boundary to draw. Now we use the paper pins to mark the incident ray. Now see both the pins from the other side of glass slab and set your eyes in this way. Both the pins comes in the straight line. as seen below the finger. Now we attach two pins other sides of the glass slab so that these four pins come in the straight line. See, we adjust our eyes in this way. These pins are come in the straight line. So one after another, we not see other pins. Four pins are in the straight line. So we draw the circle around the pins. Pick this rectangle slab. Give the name to these pins. P, Q. This is R, S. Now join the RS. This is the emergent ray. Join the RS with PQ within the rectangular slab. This is a refracted ray. Incident, refracted. This is the emergent ray. We name this M, N. Now we draw a normal at the second end of the rectangular slab. Now we measuring this emergent angle. This is also comes 45 degree. And refracted angle. This comes 29 degree. Now we mark the oval angle. This is a 45 degree, 29 degree, 45 degree. Now we produce the incident ray. Now perpendicular distance between the incident ray and emergent ray is called the lateral displacement. It is indicated by D. Lateral displacement is increased by increasing the angle of incidence or by increasing the thickness of the glass slab. Now we check this refraction with the help of the laser light. Now we place a rectangle slab in this boundary and we are using the laser light. Now we are using the laser light. We incident the laser light at the angle of 45 degree with the glass slab. Now we see the emergent light. Emergent light is also making the 45 degree angles, and this emergent light is coming at the same point where we draw the emergent ray with the help of the paper pins. Now we put off the light of the room. Now see the emergent ray of the laser light. So this is the emergent ray, incident ray, and some part of the laser light also reflected by the glass slab. But we concentrated on the incident ray and the emergent ray. Now observe the laser light without the glass slab. Now we place the glass slab. Now observe the laser light. Observe laser light is bent within glass slab. By putting light, you observe it clearly. Bending of the light rays when it passes through the glass slab. Now we are going to observe the reflection of light through a glass prism. For it, we take a glass prism placed at the center of the paper and draw the boundaries of the glass prism. Now we make an angle 40 degree with normal as shown in video. Now we are going to observe the two pins from the other sides of the glass prism, and we attach the other two pins other sides of the glass prism in such a way that four pins comes exactly in the straight line. Now to see, all the four pins are in the straight line. Now we are going to remove the pins and pick the prism. Now after we measuring the angle, we measure the angle of emergence is 62 degree, angle of incidence is 40 degree, angle of deviation is 42 degree. Angle of deviation is angle between the incident ray produced and emergent ray backward produced. It is the angle by which the ray of light is deviated when it passes through the glass prism. So incident ray is deviated by the angle of 42 degree when passes through the prism. We are going to study the refraction with the help of the laser light. We incident the laser light at the angle of 40 degree to the glass prism. Now we observe that light is emerging from the other sides, that is same angle, that is a 62 degree with the normal, as we observe with the paper plates. Now we are going to observe the refraction through the glass prism by switching off the light of the room. Observe reflection. This is the incident ray, this is the emergent ray. So light ray bends towards the base when passes through the prism. We are going to study the dispersion of the white light. For this activity, we take a prism and the white sheet of the notebook, which act as a screen. Now we incident the sunlight coming from the window on the prism at an angle. From the other side of the prism, we observe that white light is split into the 7 colors as a spectrum is formed in the other side. So prism split the white light into the 7 color. It shows white light is made up of the 7 color. We are going to show the lenses. This is a convex lens. Convex lens is thicker at the center and thinner at the edges. Concave lens, it is the thinner at the center and thicker at the edges. Now we see the printed page through the convex lens and observe. We observe words on the page appears magnified, that is, they appear enlarged in size as compared to their actual size. Now we see same words with the help of concave lens. Now we see the words are diminished. They appear small in size in comparison to their actual size. To find out the focal length of the convex lens. For this activity, we take a scale and we use the door as a screen. Now we place the convex lens close to the door and try to form the image of the outside object on the screen. Now we move the convex lens away from the screen until it forms the sharp image of the object outside the window. Now it forms the sharp image of the object outside the window. Now we can find out the focal length of the convex lens, that is the distance between the screen and the convex lens. by taking the reading of a scale. So this reading is come closer to the 9.2. So the focal length of the convex lens is the 9.2 centimeter. We are showing an activity which illustrates the focusing action of a convex lens. For it, we make a sharp image of the sun on a black paper as shown in the video. When the image is sharp, then the distance between the lens and paper is equal to focal length. As shown in the video, you observe some smoke is coming. So we'll keep steady the position of lens and paper for some time. Now you are observing some hole is formed on the paper. So keep steady the position of the lens and paper. The distance between the paper and lens is equal to the focal length. Now you observe the hole in the black paper. So this is the focus point of the convex lens. Observe the hole. Now we are going to draw the focus of the convex lens. For it, we draw a straight line. Now we take the center point of this straight line. Around this center point, we mark 2 points in the left side of this center point and 2 points in the right side of this center point. These point is at the equal distance from the center point. This distance is 2 centimeters. We mark center point is O, point around the center point F, other point beyond the F, that is a 2F. Now we take a compass and we open the compass more than the 4 centimeters. So by placing the compass point at the 2F, we make a curved surface. In the same way, we place the pin point of the compass at the another 2F and makes a curved surface. So it is a convex lens. Now we draw the focus of the convex lens. For it, number of rays are coming parallel to the principal axis. These rays are coming from the source at the infinity, like sun. Rays are coming from infinity. These rays are coming parallel to each other. After refraction from the convex lens, these rays are converged at a point on the other side of the lens. That point is called focus of the convex lens. So this is a focus. Distance between the O and F is called the focal length. Now we are going to draw the focus of the concave lens. For it, we draw a straight line. We take the center point of this straight line. Around this point, we mark 2 points in the left side at equal distance. That distance is the 2 centimeter. And the right side, we also mark the 2 points. at the distance of 2 centimeter. We take that this center point is O, and point in the left side F, another point 2F. This point is F, this is 2F. Now we place the pinpoint of the compass at the 2F and open the compass less than the 4 centimeter. This distance is the 4 centimeter. We open the compass less than the 4 centimeter and make this curved surface. In the same way, we place the compass pinpoint at the 2F, another 2F, and makes a curved surface. This makes a concave lens. This lens is the thin at the center and it is thick at the edges. We draw the number of rays coming parallel to the principal axis. These rays coming from the infinity source like sun. So these rays are coming parallel to each other. Now we draw the center of the concave lens. From the center, rays are refracted. These are the incident ray. Now we are draw the refracted ray. For it, we place the one end of the scale at the focus, other end of the scale at the incident ray where it meet the center of the concave lens. Now we draw dotted line, now solid. Next line from the focus up to the incident ray dotted, afterward solid line. Dotted line up to the incident ray, after it solid line. Dotted solid line. So these are the refracted ray. Now we are define the focus. Number of rays coming parallel to the principal axis after refraction. These rays are diverse. These diverse rays appear to come from a point behind the lens. This point is called focus. Now we are going to draw three special rays for lenses. These rays help us to know the nature, size and position of an image formed when an object is kept at the different distances from the lens. First diagram, when the ray of light is coming parallel to the principal axis. After refraction, this ray of light is going towards the focus. This is for the convex lens. Now for the concave lens. Ray of light coming parallel to the principal axis. After refraction from the center of lens, this ray is appear to come from the focus. Go. Now we are going to draw the second ray. Second ray which is passes through the optical center. This ray is passing straight without any bending. In the same way, for the concave lens is also this ray which is passes through the optical center passes without any bending. Go. Now we are going to draw the third special ray. This ray is passes through the focus. After refraction from the lens, it becomes parallel to the principal axis. In case of the concave lens, ray which is directed towards the focus After refraction, this ray become parallel to the principal axis. We are going to draw the ray diagrams of the convex lens. For first position is object is at infinity. To draw a ray diagram, we draw a long straight line. Now we mark the 5 points on the line at the equal distance. So equal distance we taken, that is a 2 centimeter. So we name the center point is O, left side point is F, another left side point is 2F, and the right side of O it is another F, this is 2F. Now we take a compass and open the compass more than the 4 centimeter. That is the distance between the 2F and O is 4. So we open the compass more than the 4 centimeter. In the same way, we place the compass pinpoint to the another 2F and make the curved surface. So we made the convex lens, which is thicker at the center and thin at the edges. Now, number of rays coming parallel to the principal axis. These rays are coming parallel to each other. These rays are coming from the infinity source like sun. So these rays are coming parallel. Now we show the refraction. We show the refraction from the center of the lens. So these rays are going towards the focus. Now these rays are meet at the focus. So position of image is at focus. When the object is at infinity, position of image is at focus. Nature of image is real, inverted and highly diminished. Now we are going to the second position. Object is beyond 2F on the convex lens. We already made the convex lens. Now we make the object beyond 2F. Now first ray going parallel to the principal axis, starting from the tip of the object. First ray going parallel to the principal axis. After refraction, this ray is going towards the focus. Second ray, which passes through the optical center, it passes straight without any bending. Now these two refractory rays meet in between F and 2F. So this is the position of the image. Object is AB, image is A dash, B dash. If we compare the size of image with the object, we observe that size of image is smaller than the object, and image is formed in the other side of the lens, so it is a real, inverted and diminished. Now we are going to draw the third ray diagrams when the object is at the 2F of the convex lens. So we draw the object at 2F. This is object. Now ray of light starting from the object. First ray going parallel to the principal axis. After refraction from the center of the lens, this ray is going towards the focus. Second ray passes through the optical center. This ray is going straight. Now these two rays are meet at this point. So this point is the image is formed. Now image is also formed at the 2f. Object is at 2f. Image is also formed at the 2f. Size of image is same as the size of the object. So when the object at 2f, image form is real, inverted and the same size as the object. Now we are going to draw the fourth ray diagrams, that is object is between f and 2f in front of the convex lens. So we draw the object between f and 2f. So first ray going parallel to the principal axis. After refraction from the center of lens, this ray is going towards the focus. Second ray which passes from the optical center, it goes straight. Now these two rays are meet at a point beyond 2f. So that is the position of image. If object is AB, image is A dash B dash. If we observe, the size of image is very large in comparison to the size of object. So we say that when the object is between f and 2f, image is formed beyond 2f. It formed real, inverted and magnified image. This position is used in the projector to magnify the image formed on the screen. So we are going to draw the fifth ray diagrams, that is the object is at focus. In all these ray diagrams we must remember that distance remains the equal, that is a distance between the OF and F and 2F, O and F and F to F, that is remain equal. In all these ray diagrams we take the distances 2 centimeters. Now object is at F. Now first ray coming parallel to the principal axis. After refraction from the center of the lens, this ray is going towards the focus. Second ray which passes through the optical center, it passes straight without any bending. Now we observe both refracted rays are going parallel to each other. So these refracted rays may meet at the infinity. So we say that image formed at the infinity, image is real, inverted and highly magnified. Now we are going to draw the sixth ray diagram, that is object is between O and F of convex lens. So object is between O and F. First ray going parallel to the principal axis. After refraction from the center of lens, this ray is going towards the focus. Second ray which passes through the optical center, it goes straight. Now observe both rays. We observe distance between the both rays is increasing as the rays are moving away from the center of the lens. So these rays are never meet in the other side of the lens. So we produce these refracted rays backward in the dotted line. Same way. So these two refracted rays meet at this point. It is called, if it is AB, this point is B dash and this is a dash. So this is the AB is the object, A dash, B dash is the image. If we compare the image with the object, we observe size of image is very large and image is formed in the same side of object. So it is a virtual, erect and magnified. Now we are going to draw the ray diagrams of the concave lens. For first position is object is at infinity. Firstly we will draw the concave lens. For the concave lens, firstly we draw a long straight line. Now we mark the 5 points on the line at equal distance. As we does in the convex lens. So we take the distance 2 centimeter. Name the center point is O. Left side first point is F. Left side second point is 2F. In the same way, the right side first point is F. Second point is 2F. Now we take the compass. Now this time we open the compass less than the 4 centimeter. It is a distance between 2F and O is 4 centimeter, but this time we open the compass less than the 4 centimeter. In the same way, place the pinpoint at another 2F and make the curved surface. Now this is the concave lens, which is thin at the center and thick at the edges. Now number of rays coming from the infinity sources. These rays are coming parallel to each other. To draw the refracted rays, one end of the scale at the F, other end at the ray where the incident ray touch the center of the lens, and draw the refracted ray. Firstly dotted line, here is solid, so this is the refracted ray. Same way, solid, dotted, solid. So when the ray of light coming parallel to the principal axis, after refraction, these rays are diverse. These diverging rays are appear to coming from a point behind the lens. That point is called focus. So we say that when the object is at infinity, image is formed at the focus. Image is virtual, erect and highly diminished. Now we are going to draw the second position in front of the concave lens, that is object is beyond 2F. So we draw object beyond 2F. First ray going parallel to the principal axis. After refraction, this rays appear to come from focus. Second ray, which passes through the optical center, goes straight. These two refracted rays are meet between O and F. So this is the position of image. If object is AB, then image is A dash B dash. We observe that size of image is very small in comparison to the object, and image is also formed in the same side of object, so it forms the virtual, erect and diminished image. Now we are going to draw the third ray diagram, that is object is between F and 2F in front of the concave lens. So first ray going parallel to the principal axis. After refraction, these rays appear to come from focus. So draw the refracted ray this way. Second ray which passes through the optical center, it goes straight without any bending. So we again observe image is formed between the O and F. If object is AB, image is A dash B dash. In this case also, image is virtual, erect and diminished. So from these two diagrams we say that whatever the position of the object in front of the concave lens, that is between optical center and infinity, image is always formed between the O and F, and image is always virtual, erect and diminished.